Remember, section 15.2 is the one that dealt with simplifying radicals. And that's a couple worksheets you had was due today on that. So if you want to simplify, and let's say you had 2 square root of 32. How would you simplify that radical? What would we be looking for? A perfect square, because the index is 2, square root, the index is 2, so you're looking for a perfect square. And always try using the largest. So what's the largest perfect square that goes into 32? 16. So the way you want to do this is you want to say, well, that's going to be 2 square root of, and then you're going to rewrite 32 using that perfect square. So you're going to say 16 times 2. And then you're going to rewrite the square root of 16 times 2 as the square root of 16 times the square root of 2. Now you could skip some of that and do some of it in your head. And then we know that the square root of 16 is exactly what number? 4. So that's 2 times 4 times the square root of 2. And so what's the answer? 8 square root of 2. Okay? Now it's always helpful to use the largest perfect square, because if you did not use the largest perfect square, this is what you would have to deal with. So let's suppose you use 4. 4 is a perfect square, correct? And 4 goes into 32. So you said, well, that's going to be 2 times the square root of 4 times 8, right? Now remember, you always use a product where one of them is a perfect square. And so you're going to then say, well, that's going to be 2 square root of 4 square root of 8. And what's the square root of 4? So that's 2 times 2 square root of 8. And what's 2 times 2? So that's 4 square root of 8. But that's not the answer, because the direction said to simplify. So you look at this, I can simplify the square root of 8 further. What perfect square goes into 8? 4. So then you would have to say, all right, well, that's going to be 4 times the square root of 4 times 2. And then, you don't have to write all this. You could circle this right then and say the square root of 4 is what? 2. So you'd say 4 times 2 square root of 2. So what's the answer? 8 square root of 2. So notice it's a lot easier to use the largest to begin with. All right, so that's one of the things we talked about. Okay? Then I think we started talking about something like this. And well, actually we did this in a previous section. What is the square root of x to the 10th power? Now let's assume, since we limit square root, let's assume that the variable represents positive numbers. That's just x to what power? The 5th. All right? But then in section 15.2, we started talking about, well, what if you had this? What if you had the square root of x to the 13th power? See, this one was easy right here because the index, both the index and the exponent were even, right? And 2 goes into 10 evenly, so that's 5. Here, though, that's a 13. So when we did the long way, the mathematical way, we said, well, what's the largest number less than 13 that 2 goes into? 12. So we wrote this as the square root of x to the 12 times x. Because remember, when you multiply like base, you do with those exponents. You add 12 plus 1 is 13. But then just like we've been doing here, this becomes the square root of x to the 12th times the square root of x. And what's the square root of x to the 12th? X squared. I'm sorry, x to what power? X to the 6, right? So it'll be x to the 6 to the square root of x. Okay? All right, then we start talking about something like this. Well, what if you had, again, this is all simplified. So if you had the square root of, let's say, 81, x to the 21st power. Where do we have that? Well, what do you say about 81? It's already a perfect square. So the way that you may want to do that is rewrite the x to the 21st power. So you may want to say, well, that's going to be the square root of 81. Don't rewrite 81. Leave 81 as 81 because it's already a perfect square. But I can rewrite x to the 21st. What's the largest exponent, or let me rephrase it. What's the largest number, largest whole number, less than 21 that 2 goes into? 20. So it'll be x to the 20th times x, right? And so mathematically, what happens is that this really becomes the square root of 81 times the square root of x to the 20th times the square root of what? X. What's the square root of 81? What's the square root of x to the 20th? And then what's left? Square root of x. So there's your answer. 9x squared, square root of x. Okay? So that's a more conceptual framework here. Now, some students like using a shortcut, but that's a shortcut with no really understanding to it. They'll just say 2 into 21 is, they'll say 2 into 21 is what? 10? With the remainder of what? 1? So the 10 it goes on the outside and the 1 goes on the inside. But that is there's just some memorization there. I wouldn't do that approach, but that's sometimes what they'll do. But it's a way to check yourself. 2 goes into 21, 10, so you got to make sure your answer has x to the what? 10th power. And what was the remainder? 1. And in fact, if you think about it, since I'm dealing with the square root, when I simplify, if you look at all the problems we've done, when I simplify, that exponent is always going to be what? Exponent under here is always going to be what? 1. 1. It's always going to be 1. All right, so if you had the square root of, let's say, 16, x to the 12th power, y to the 9th. And some of you can do this in your head real easily. I'm not going to say show work here, but for some others, you may need to show some work. First of all, let's talk about 16. 16 is a perfect square. And 12 is even, so that's a good one. But what's the issue? The 9. So in your mind, you know this. You know that this right here that I'm circling, automatically gives me what? 4x to the 6th. And what am I left with? Square root of y to the 9th, right? Mm-hmm. Now let's deal with the y square root of 9. Square root of y to the 9th. What's the largest number less than 9 that 2 goes into? 8. So if you want to go off to the side and figure that out right here. So it'll be the square root of y to the 8th times what? Y. And what's the square root of y to the 8th? So you're left with y to the 4th, square root of y, right? Mm-hmm. So that goes here. So it's going to be the answer. 4x to the 6th, y to the 4th, square root of y. Okay? That's all you had. All right, then what if you had the square root of, let's say, let's say 27 x to the 26th power. Square root of 27 x to the 26th power. Well, in the previous ones we did a while ago, those were all perfect squares, but is 27 a perfect square? No. But what perfect square goes into 27? 9. Now, if you want, you can rewrite this as square root of 27 times the square root of x to the 26th. This one that I have circled, that's easy. What's the square root of x to the 26? X to the 13th. So that's x to the 13th. So really I have the square root of 27 times x to the 13th, correct? Now let's talk about the square root of 27. What perfect square goes into 27? Besides 1? 9? In fact, that's the only other one, right? So it becomes the square root of 9 times 3 times x to the 13th. And what's the square root of this 9 right here? All right, now we always put the radical on the end. The square root, always put on the end. So when rewriting this, don't, even though it's equivalent, even though you could say 3 square root of 3 x to the 13th like that, put the radical on the end. So in other words, I want the answer to be, and put the number in front. So it'll be 3 x to the 13th times the square root of 3. Okay? So we tend to put the square root on the outside. And there's a variable involved, we put it right in front of it. And then the coefficient in front of that. All right, so then let's suppose you had all right, square root of 125 x to the 7th, y to the 10th. So okay, if you need to rewrite that product as separate square roots, in other words, now you know that 125 is not a perfect square. So rewrite it as square root of 125 times the square root of x to the 7th times the square root of y to the 10th. Do it that way. And you simplify each part. And if you need to, go off to the side and figure that out. Square root of 125 like this. What's a perfect square that goes into 125? 25. So that's square root of 25 times 5. And what's the square root of 25? So square root of 125 is what? 5 square root of 5. So that's this right here. Okay? Now let's talk about the square root of x to the 7th. What's the largest number less than 7 the 2 goes into? So that's square root of x to the 6 times x. What's the square root of x to the 6? That's x to the 3rd square root of x, right? You agree? So that goes here. So times x cubed square root of x. And then square root of y to the 10th, that's just what? Y to the 5th. Okay, so that's where I'm at. Okay? So a bunch of little factors to see here. You see 5, you see square root of 5, you see x cubed, you see square root of x, you see y to the 5th. Something else you got to remember is this. You remember when we split this up, when I said 4 times x, and I said that's the square root of 4 times square root of x, right? Yeah. So I wrote the square root of a product as a product of 2 square roots. So you can go backwards as well. So the square root of 4 times the square root of x, you can write as 1 square root. You just do what to those radicands? Multiply them. So the square root of 4 times the square root of x is the square root of what? 4x. Okay? So here, you see how you have the square root of 5 and the square root of x? You want to write as 1 square root. You want to write this as 1 square root. So the square root of 5 times the square root of x is what? Square root of 5x. So that's going to go off to this on the end, right? And then put everything else in front. Okay, so the variables go in front and the number goes in front of that. So what's going to be in front of that? 5 x cubed y to the 5th square root of 5x. So 5 x cubed y to the 5th square root of 5x. Okay? All right, what if you had this? Let's do another one like that. So what if you had the square root of 98 x to the 6th y to the 9th z to the 15th. So square root of 98 x to the 6th y to the 9th z to the 15th. A lot of things there, so break it down though. break it down. It's not as easy as the worksheet you turned in today. That worksheet was easy compared to this one. So split it apart. So that the square root of all this product, write them as the product of each square root. So it'll be the square root of 98, square root of x to the 6th, square root of y to the 9th, square root of z to the 15th, right? And then go off to the side and then figure out what each of those things are. So let's start with the square root of 98. What perfect square goes into 98? 49. So that's the square root of 49 times 2. And 49 is a perfect square, so that means the square root of 49 is what? So that's 7 square root of 2. So that's right here, 7 square root of 2. Okay? Now remember, 7 square root of 2 means 7 times the square root of 2. That's a product. X to the 6, that's easy. That's just what? X to the 3rd. All right, let's go off to the side and figure out what the square root of y to the 9th is. What's the largest number less than 9 that 2 goes into? 8. So it's y to the 8th times y. And what's the square root of y to the 8th? So that becomes y to the 4th times the square root of y. So that goes here. Y to the 4th, square root of y. That's a 4th. Then you do the same thing with the square root of z to the 15th. Z to the 15th. What's the largest number less than 15 that 2 goes into? 14. So z to the 14th times z. What's the square root of z to the 14th? Z to the 7th, and you get z to the 7 times what? Square root of z. So that goes here. Z to the 7th, square root of z. See what I did? That's all you do, each one. And now you write it in a better looking way. All the square roots you write as 1. Square root of 2, square root of y. Let me write it out. Look, square root of 2, square root of y. That's a y. Square root of 6. Oh, I'm sorry. That's a z. Excuse me. That's a z. Square root of z. So, right, this is 1 square root. So that's square root of what? 2yc. Okay? That's what that is. So, to make it look better, though, remember the radical goes on the outside. So the square root of 2yz is going to go on the outside. So it's going to be your answer. 7, x to the 3rd, y to the 4th, z to the 7th, square root of 2yz. Okay? Any questions? That's all that is. So, when you look at 15.2 Part C, that's all we've been doing. The last class period and today. That's all this is. All right, except this one's a little bit simpler than the ones that we just did a while ago. All right, some of these are perfect squares, some are not. And and remember how we did the square root. So on the worksheet you turned in today, you set the square root of the numerator divided by the square root of the denominator. Right? Okay. All right, any questions on this? All right, so it's not that difficult. You can handle this. All right, now, you have any other worksheets you got to turn in?
Those are mine.
Okay, y'all finish all the worksheets?
I did, yeah.
Okay. All right, everyone's turned in the worksheets? Because the keys are up there. Okay, keys are up there. All right. Now, let's look at this. Suppose you had one plus the square root of 25 divided by 2. 1 plus the square root of 25 divided by 2. Okay? What's the square root of 25? 5. So you can simplify the square root of 25, right? So that becomes 1 plus 5 divided by 2. And using the order of operation, I do the numerator first. What's 1 plus 5?
6.
6 divided by 2 is 3. Okay? No big deal. Okay? So if you had 3 minus the square root of 36 divided by, let's say, 8, how would you simplify this?
The square root of 36 is 6.
Square root of 36 is 6. So I get 3 minus 6 divided by 8. What's 3 minus 6?
3.
Negative 3 eighths. And I can't reduce anything, so you're done. Okay? All right. Now, sometimes you will see this. 1 plus or minus 3. Let's say I had 1 plus or minus 3. Whenever you see that 1 plus or minus 3, what that means is that this expression can be written as 1 plus 3 and then 1 minus 3. Okay? 1 plus 3, 1 minus 3. That's what that means. And then so what's 1 plus 3? 1 minus 3, negative 2. Okay? So that's what that plus or minus means. So when you see that plus or minus, it means there are two things involved, two expressions involved. One's a plus, one's a minus. 1 plus 3, 1 minus 3. 1, let's do negative 3 plus or minus 4 divided by 7. Negative 3 plus or minus 4 divided by 7. See that plus or minus, right? So that means I can rewrite this as two separate entities, two separate expressions. First will be negative 3 plus 4 divided by 7. And the next is going to be negative 3 minus 4 divided by 7, right? What's negative 3 plus 4? So you got 1/7. And then what's negative 3 minus 4? Over 7, which is just negative 1. Okay? So all of this right here is going to take us into the first part of solving quadratic equations using the quadratic formula. Section 15.3, solving quadratic equations using the quadratic formula. Okay? And it's very simple to use. If you understood what we just did here, you should be okay. Because the first part deals with perfect squares. That's all it is. Perfect squares. And that's what you have to turn in today. Stuff dealing with perfect squares. Now, here's a quadratic formula. So remember on the last test, you had to solve quadratic equations using you had to solve quadratic equations by what? Factoring. All right, so you factored and you said each one equal to 0, right? You agree? All right. But then remember, when we first talked about this, the only reason why you could do it that way is because those quadratic equations were factorable. Not all of them were factorable. So that's where the quadratic formula comes in. I'm just going to tell you what the quadratic formula is. In order to understand where it comes from, you have to know something called completing the square. And so completing the square you're going to do next semester. So we're just going to give you the formula. So here's the formula for solving quadratic equation by the quadratic formula. So remember, the standard form of a quadratic equation looks like this. ax squared plus bx plus c equals 0. That's the standard form of a quadratic equation. And that's what you solved in the last test. If you look at your test, and even the test before that, you had a couple of problems you had to solve by factoring. the quadratic formula says this: no matter what kind of equation I have, whether it's factorable or not, I can solve this using the quadratic formula. So here's the quadratic formula. I'll give you the quadratic formula, you just need to know how to use it. You don't know where it comes from, you have no idea where this is coming from. Just know how to use it. Okay, so notice the coefficient of x squared is what letter? A. Coefficient of x is what letter? B. And your constant is represented letter C. Okay? So in the quadratic formula, you're going to see those variables, those letters. So the quadratic formula says your solutions, and I'm solving for what variable here? What's my variable? X. Your variable is x. That's what you're solving for. So my solution is going to be x equal, remember when you solved using factoring, you said x equal, x equal? That's your variable. So x equals the opposite of b. This means the opposite of b. So whatever b is, you're going to do what? Take the opposite. Plus or minus, that's where the plus or minus comes from. That's why we talked about it here. Now you have no idea where that comes from because we haven't done completing the square. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's quadratic formula. That allows you to solve any quadratic equation, whether it's factorable or not. Again, you have no idea where it comes from. I'll give it to you, just know how to use it. Okay? All right, so let's look at one of them. So this is going to be number, and the rest of this is just plug and chug, by the way. And you need your calculator in some of this, because some of these numbers are not small numbers. And I said this is 15.3.
Yes.
I meant 16.3. Excuse me. 16.3. Okay, 16.3. Okay, so the direction to say solve using the quadratic formula. So if it says solve using the quadratic formula, you have to use the quadratic formula. All right, solve using quadratic formula. Here's number one. Your equation, this is actually on page 1185. And it's going to be number 2. So this is problem number 2 on that page. All right, so we have x squared minus 5x minus 6 equals 0. X squared minus 5x minus 6 equals 0. Okay? Now, it just so happens that this quadratic equation is factorable. So you could have done that on the last test. But what the direction says, does it say solve by factoring, or does it say solve using quadratic formula? Solve using quadratic formula. Okay? So always make sure you follow the directions. Solve using quadratic formula. So if I'm going to use a quadratic formula, I need to know what A, B, and C are. Before I determine what A, B, and C are, I've got to have this in standard form. Okay, standard form. Is this in standard form? Yes. So now tell me what A is. So A equals what? 1. Coefficient of x squared. What's the coefficient of x squared? 1. B equals what? Not 5. Negative 5. The coefficient of x. It's negative 5. Not 5 and not 5x. It is negative 5. And what is your constant C? Negative 6. So 1 for A, B is negative 5, and C is negative 6. Once you determine that, then you just got to take those numbers and plug them back into the formula. And now that's where the plug and chug comes in. Okay, so here's what you do. So my variable is x. I would say x equal. This says my numerator of the quadratic formula says the opposite of b. But what is b? So what's the opposite of negative 5?
5.
So that's 5 plus or minus the square root of. And then for the radicand, that b squared minus 4ac, for that radicand, put everything else in parentheses. So in other words, see where I'm squaring that b? What is b here?
-5.
So that becomes negative 5 raised to what power? Second, minus 4 times in parentheses, what's a? 1, and in parentheses, what's c? Negative 6. All over. See, all this, make sure this whole thing is being divided by. Make sure that you extend the line. Okay? 2 times a, what's a? 1. So that's your first step. So notice all I did was just take those numbers and plug them back in. Okay? But keep in mind that in the radicand, make sure you put all those in parentheses. Because if you did this right here, if you didn't do this in parentheses, remember last semester there was a difference between this versus this. What is this right here that I'm circling? Negative, oh yeah, okay, but what's negative 5 times negative 5? 25. What is this right here? Negative 25. So whenever you square b, whenever you square something, it has to be positive. So some students will make the mistake and say that's a negative 25, which is not. It's supposed to be what? Positive, because you're squaring a number. Whenever you square a number, it's either positive or 0. Okay? Never negative. So that's why the parentheses are important. So what I would do next is this. I would go ahead and start simplifying the radicand. So I'm going to say 5 plus or minus the square root of. What's negative 5 squared? 25. All right, now use your calculator if you need to. A negative 4 times a positive 1 times a negative 6. What is that? A negative 4 times a positive 1 times a negative 6. Positive 24. So the radicand becomes 25 plus 24. All over what number? 2. So that'll be your next step. So you start simplifying the radicand and do one thing at a time. Now let's simplify the radicand even further. What's 25 plus 24? So I get 5 plus or minus the square root of 49 divided by 2. And now that looks like what we did on the previous page. Simplify. What's the square root of 49? That becomes 5 plus or minus 7 divided by 2. And remember, that's where we say we're going to rewrite this. So how do you rewrite this? 5 plus 7 all over 2, and then what? 5 minus 7 all over 2. What's the numerator? And what's 12 divided by 2? Good. What's the numerator? Negative 2. What's negative 2 divided by 2? So what are your solutions? X equal 6 comma negative 1. 6 comma negative 1. Those are your solutions. And you can check. Let's do the 6. 6 is easy to check. You go back to the original, right? What's 6 squared? What's 5 times 6? So what's 36 minus 30? And what's 6 minus 6? 0. So 6 works. Let's do negative 1. What's negative 1 squared? Positive 1. Negative 1 times negative 1 is a positive 1. What's the negative 5 times a negative 1? Positive 5. A negative times a negative is a positive. So what's 1 plus 5? And what's 6 minus 6? 0. Okay? Now, remember I said on the last test you did this by factoring? Now, granted, the factoring is a lot quicker. But are all quadratic equations factorable? No, if they're not, you have to use quadratic formula. Let's do this one by factoring, just to remind you. So we're going to do the same one by factoring. Remember the directions. So the directions say solve by factoring. Okay. So remember, in the previous test you factored, right? So you say XX, what are the possibilities for 6? 3, 2, 6, 1, what do you think is going to work? 6, 1, not 3, 2. 6, 1. Because the last sign's negative, so that means the signs in here have to be different. 6 has to be negative, 1 has to be positive. Then what else did you do? You said each one equal to 0. So you said x minus 6 equals 0, x plus 1 equals 0. So what are your solutions? 6, comma, and what's the other one? See how quicker it is to factor? So it is easier to factor than it is to use the quadratic formula. But not all equations are factorable. So you have to know use the quadratic formula. Okay? All right, so let's do another one with quadratic formula. So this is going to be number 26. 26. Okay, 26. You have 5y squared equals 4 minus y. 5y squared equals 4 minus y. And you had this idea in the previous test, and even on that. So if I'm going to solve this by factoring, what did you have to do first in the last two tests? Put in standard form and put in descending order. So how would you rewrite this in standard form? 5y squared plus y minus 4 equals 0. All right, and then you factored, but remember the direction says solve by using a quadratic formula. So what's the standard form? Then you determine A, B, and C. So what's A? 5. What's B? 1. And what's C? Negative 4. Okay, now guys, if any of these numbers are incorrect, then your answer will be incorrect. Okay, so be careful. Make sure, first of all, before you go any further, that what you have at A, B, and C is actually correct. Then you can take those numbers and plug them back into the formula. So remember the formula is this. Negative b, the opposite of b, plus or minus the square root of b squared, minus 4ac, all over 2a. So your denominator is 2a. All right, so let's, now remember, your variable is what this time? Y. So you're going to say y equals, all right, the numerator. Let's do the numerator first. Numerator says the opposite of b. What's b in this case?
1.
So what's the opposite of 1?
Negative 1.
-1. Plus or minus the square root of, and remember how we did the previous one, put everything in parentheses. What's b?
1.
So I'm going to say 1 in parentheses squared minus 4 times a in parentheses. What's a?
5.
5 times c, negative 4. And you see how I have that division symbol that underlined all the way across? All over 2 times a, and what's a? 5. So that's where I'm at. So all the first thing you do is you plug in those numbers just like that. That should be easy. Then the next thing you're going to do is simplify the radicand. So what's underneath? So you're going to say equals -1 plus or minus the square root of, and that's where you're going to start simplifying. What's 1 squared? 1. Okay, now let's do this one. -4, you may need to use your calculator. -4 times 5 times a -4.
80.
Plus 8 or minus 80?
Plus.
Plus 80. All divided by what number? 10. That will be your next step. Not difficult. You just do one thing at a time. Now let's rewrite that radicand. What's 1 plus 80? 81. So that's -1 plus or minus the square root of 81 all over 10. And you know how to simplify the square root of 81. What's the square root of 81? So that's -1 plus or minus 9 divided by 10. And now you're going to rewrite this as 2 fractions. -1 plus 9 divided by 10. And then what? Negative 1 minus 9 divided by 10. What's the numerator of that first one?
8.
8 over 10, which reduced is 4 fifths. Next one. Negative 10 divided by 10, which is negative 1. So you found your solutions. My solutions are y equals 4 fifths and what? Negative 1. There's your solutions. All right, let's do one more with this. Actually, two more. Let me see if I can find one. All right, so it'll be number 36. Okay, so the next one, you should know how to do this now with these perfect squares. You have 5x squared. Well, actually, let me do this first. Let me write it like this. I'm rewriting number 36. Same problem, but I'm just changing the order. Negative 13x equal 6 minus 5x squared. Negative 13x equals 6 minus 5x squared. All right, before we go on, when you put in descending order and put in standard form, you always want to try and get a to be positive. So if you look at it right now, what is a? Negative. So let's bring everything to the other side, and let's put in descending order. Okay? So when I do that, when I bring everything to the left side, what is it going to become? Minus 6 equal 0. All right, what's A?
5.
What's B?
Negative 15.
What's C?
Negative 6.
All right, and then I just plug and chug. So remember your formula is negative b, the opposite of b, plus or minus the square root of b squared, minus 4ac, all over 2a. All right, the variable is x, I'm going to say x equal. All right, what's the opposite of b? 13, positive 13. b is negative 13, the opposite of that is a positive 13. Plus or minus the square root of, now remember that the radicand is where you put those parentheses. So I'm squaring b. What's b? In parentheses, I'm going to square it. Minus 4 times a. What's a? 5 times c.
Negative 6.
Yes, negative 6. Thank you. All divided by 2 times a. What's a? 5. All right. So I simplify the radicand. So that becomes 13. Plus or minus the square root of, what's a negative 13 times itself? 169. What's a negative 4 times 5 times a negative 6? Be plus what? Positive 120? I'm just writing what you're telling me.
Yeah, it's 120.
Okay. All divided by 10, right?
Yes.
So that equals 13 plus or minus the square root of, what's 169 plus 120? 289
Yes.
divided by 10. All right. Now, you may not know what the square root of 289 is, so use your calculator. So take your calculator out. And you got to know what the square root button is. So we're trying to figure out if the square root of 289 is a nice number, a nice whole number. We're meaning that 289 is a perfect square. So let's see if it is. So you're going to say square root, so that's right above the x squared. So you say second x squared, you get the square root. Then 289, and then press equal, and you get 17. So the square root of 289 is what? 17. So I get 13 plus or minus 17 divided by 10. And that's where you would rewrite this. You would rewrite this as 13 plus 17 divided by 10. And what's the other one?
13 minus 17 divided by 10.
So what's the numerator of that first one? 30 divided by 10, which is 3. The next one, that's going to be a negative 4. tenths reduced negative 2/5. And so your solutions are going to be x equal 3 comma negative 2/5. Okay. All right, now let's do one more with this. Now notice that all of the radicands were perfect squares, right? Okay. So that's the part one, where all the radicands are perfect squares. Let's look at this one. Okay, so let's say we had write this example. Suppose you had 4x squared minus 4x plus 1 equals 0. 4x squared minus 4x plus 1 equals 0. All right. What's A? First of all, it's in standard form, right?
Yes.
Okay, what's A?
4.
What's B?
-4.
And what's C?
1.
1. So the formula is the opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. So I say x equal. If B is -4, what's the opposite of that? 4. Plus or minus the square root of. What's B? What's B? -4. I'm squaring that, right? Put -4 in parentheses. Minus 4 times A. What's A? Times C. 1. All over 2 times A. And what's A? Positive 4. Okay, let's simplify the radicand. 4 plus or minus the square root of what's -4 squared? 16. Now what's a -4 times 4 times 1? -16 all over 8. Simplify the radicand. That becomes 4 plus or minus the square root of what? 0. Divided by 8. What's the square root of 0? 0. So 4 plus or minus 0, look at what I have, 4 plus or minus 0, right? But 4 plus or minus 0 is just what number? 4. That's all it is. So I only get one solution. It's just what? 4/8, which is equal to 1/2. So the previous ones we had two solutions. All right, so this one we had one solution because the radicand happened to be what number? 0. So that's why you only end up with one solution. Now I want to remind you about this though. If we did this by factoring, just to remind you, if we did this by factoring, I want you to remember something about the factors. If I factor this, that's going to be 2x, 2x, and what's the only possibility for 1? 1 and 1. The last sign's positive. These signs have to be the same. Remember, when we talked about solving quadratic equations by factoring, what did you notice about these factors here? They're the same. So we only used one of them. So 2x minus 1 equals 0. So what's x? 1/2. All right, so there's a relationship between the two. So you should get one solution because when you factor, you only have one solution. It just turns out that the reason why you had one solution to begin with when using a quadratic formula is because the radicand was 0. Okay? All right, so that part 1 worksheet, is just on this kind. So there are 6 problems. And notice it says solve each using quadratic formula. Show all work. So I need you to show the work. if there's enough room, you can go ahead and redo it on another sheet of paper because I don't think I really put enough room here. But remember, you got to put this in what form? Standard form. Okay? Standard form. Notice that this is y, so when you do it, you say y equals, okay? All right, standard form. All right, so that's all this is. Okay? Now remember, use the quadratic formula. Use the quadratic formula. All right, that's that first part. That's part A. Okay? Now, watch this one now. It's going to review something. So a while ago, we had this. We had 2 plus and minus, well, let me just do this. 2 plus the square root of 16 over 7. And the square root of 16 is what? 4. So it's 2 plus 4 over 7. And I can combine 2 and 4, right? What's 2 and 4? 6. So that's 6 divided by 7. Okay? All right, now, what do we have this? 2 plus the square root of 8 divided by, let's say, 3. 2 plus the square root of 8 divided by 3. Now we're getting to the point where the radicand is not a perfect square. All the ones we had a while ago were what? Perfect squares. But use what you learned before. We got to simplify the square root of 8. You had that before. How do you simplify the square root of 8? You look for perfect square that goes into 8, which is 4. So that'll be the square root of 4 times 2, and what's the square root of 4? So that's 2 square root of 2. So I'm going to rewrite the square root of 8 using this. So that's 2 plus 2 square root of 2 divided by 3. Okay? All right. Now, so not all, when I mentioned the word radicand, everyone we've done was a perfect square, and then there was a 0, right? Now we're going to get in a situation where it's not a perfect square, but you're still simplifying it using a perfect square. Now I want you to notice something. When I simplified this, 16 is a perfect square. What's square root of 16? 4. Why was I able to write this as one term? Why was I able to write 2 plus 4 as one term? Because I can combine them because they're both integers. I can combine integers. 2 plus 4 is 6. Okay? You can think of these as like terms, so to speak. I can't combine these two. I cannot say that 2 plus 2 square root of 4, 2 plus 2 square root of 2 is 4 square root of 2. That is not true. That is not true. It's kind of like saying this, 2 plus 2x. Can I combine 2 plus 2x? No, they're not like terms. That is not equal to 4x. Same idea here. 2 plus 2 square root of 2, it's kind of like saying, how many square root of 2's do you have? It's just like here. How many x's did I have here? I had how many here? 2. How many here did I have? None. So how many x's do I have altogether? Still 2. Not 4. How many square root of 2's do I have here? 2. How many do I have in this one? None. So I don't have 4 of them. I still have just what? 2. So you can't combine these. Okay? So when we start talking about this type of problem now, in the previous section, in the previous part, the part 1 or part A, I'm able to write these as fractions. If you go back to all of them, I'm able to write this as fractions because my radicand was a perfect square. And then I can combine these integers, 4 and 0 integers. 2 is an integer, but 2 square root of 2 is not an integer. Remember your integers? What are your integers? your integers are 0, 1, 2, 3, 4, and so on, and -1, -2, and so on, right? Those are your integers. 2 square root of 2 is not an integer. All right? Okay. Now, one of the things I'm going to ask you to do is to round this off. Let's use your calculator. Let's start looking at this calculator. So, we're going to do both of them. So on the calculator, you're going to say 2 plus the square root of 8, 2 plus the square root of 8. All right, you got to press equal though, because all I'm doing is finding what's in the numerator first. So I found the numerator, I'm going to press equal, and this is my numerator. Okay? 4.8 and so on. Don't round off, leave that in your calculator. Then you can divide by the denominator, and what's my denominator? 3, and you can press equal, and that's what this is approximately equal to. So 2 plus the square root of 8 divided by 3 is approximately equal to 1.6094, and so on. On the worksheet, it's going to say round to the nearest tenth. So the nearest tenth, this is 1.6 or 1.7? 1.6. Okay? What should this one be right here? To the nearest tenth, what should that be? Same thing, because those are the equivalent expressions. So now here's how you would do that one on your calculator. Same idea, you're going to say 2 plus 2 square root of what? 2. See how it looks? 2 plus 2 square root of 2, press equal. There's your numerator, same one as before. Divide by what? 3, and you get the same thing. Okay? 1.7. Any questions? All right, so let's look at this. Suppose you had, oh, I put 1.6. I meant to say 1. What? 7. That's what I meant to say up here, 1.7 to the nearest tenth. All right, so let's suppose we had -3 minus the square root of 32 divided by 6. -3 minus the square root of 32 divided by 6. Okay? Is 32 a perfect square? No, but if it was, it would make things a lot easier for us. But it's not, but I can still handle it. What's the largest perfect square that goes into 32? 16. So I'm going to write this as -3 minus the square root of 16 times 2, right? All over what? 6. What's the square root of 16? So it becomes -3 minus the square root of, square root of 4 is 4, right? So square root of 16 is 4. So 4 square root of 2 all over 6. Y'all agree? -3 subtract 4 square root of 2 over 6. All right? Can I combine the numerator like I did in the previous part? No. Because they're now both integers. -3 is an integer, but 4 square root of 2 is not. So that will be your exact answer. Now let's approximate the nearest tenth. Let's use the calculator. And let's just use the calculator on this one. For right now, let's do that one first. So on your calculator, you're going to say -3 minus 4 square root of 2, and you're going to do what? Press equal. Then divide by what? 6, press equal, and then to nearest tenth, that's going to be -1.4. Now, the idea of using a calculator here to approximate, you're going to need next semester, because next semester you'll be graphing these quadratic equations. And so you have to approximate at that point the quadratic equation to graphing those. So you need to remember how to use your calculator with the approximations. If I had used this one to approximate, I should still get what? same thing. So negative 3 minus the square root of, oops. So negative 3 minus the square root of 32, and I press equal and divide by what? 6, and I get the same thing, negative 1.4. Okay? Now, when we so we're going to do next class period is remember in this class period we talked about solving quadratic equations using quadratic formula. The radicand was a perfect square. The next part B of this section, the radicands are not a perfect square. So we're going to talk about how to deal with those. Okay? All right, so I'm going to give you the part A. So this is part A. So part A should be easy. You're probably not going to have enough room here, so if you want to put the work on another sheet of paper, step by step, that's fine, and then just put the solutions in here. All right, there's 6 of them. They're all perfect squares. Okay, so there should be nice numbers right here. Your answer should be your solutions should be integers. Excuse me. They're not all integers. Like 1/2 is not an integer. 1/2 is a rational number. Let me rephrase it. They all should be rational numbers. Okay? Remember when I said they all should be integers? That's not true. Because 2/3 is not an integer, right? Okay. But it's a rational number. Remember we talked about rational number. Rational number is where you have an integer divided by an integer. All right. And then so you have, a week from today, you have 15.2 part C. That's one we did beginning of class. And then you have part A of this, okay? All right, so you can work on these at this point.